Hello and welcome to another episode of Containers from the Couch. Today, we're going to be focusing on running Windows workloads on AWS, specifically on Amazon EKS. We've got a demo-packed episode today. I'm joined by my co-host, Justin Garrison, as well as three members of the AWS team here focusing on Windows workloads. So happy to have you guys on today. I want to start, Purvi, with you. I'd love to hear from you what you do at AWS and maybe talk a little bit about why the growth for Windows containers on AWS has been so explosive.
Absolutely, Sai. Thank you so much, by the way. Hi, everyone. My name is Purvi Goyal. I work as a product manager here at AWS, supporting Windows workloads and all compute platforms, including EC2, ECS, EKS, Fargate. I've been here a little over 5 years now, and of late, of course, I've been focusing a lot more on containers because our customers have been focusing a lot on containers. So I guess to go back to your question there, Sai, a lot of our customers who run .NET workloads on Windows, a very easy way for them to add scalability and standardization, of course, is to move to containers. We see a lot of our customers wanting to modernize some of their older .NET Framework workloads, and containerization essentially gives them a very easy way for them to reduce their total cost of ownership without really having to spend a ton on re-architecting their workloads. Of course, when customers run and operate plain Windows Server VMs, they need to worry about endpoint protection, monitoring, and overall management of their Windows nodes. Of course, having to deal with blue screen of death is not fun. And all of that essentially goes away when customers move to Windows containers because they don't really need to update their Windows worker nodes, and essentially they can spin down and spin up any new containers with latest updates. So all in all, it is a great way for customers to modernize their workloads without having to put a lot of effort into doing so, and get the benefit of reducing their compute costs, and an easy way to just manage their workloads without having to manage a lot of overhead into managing infra.
Excellent. Thank you for that intro. Next, I want to jump to Marcio. Marcio, tell us a little bit about what you do at AWS. And that shirt, I love that shirt. Containers are not a security boundary. Tell me about that as well.
Well, so Marcio Morales, I work as a principal solution architect on AWS, and my focus is on Microsoft workloads. I have been on AWS for a little over 5 years now, and I heavily focus on Windows container for 2 years and a half, pretty much. And containers are not a security boundary. For sure, this is a wholly new discussion, but people really need to understand that while you are sharing kernel with process, because containers by the end of the day is just an isolated process in the operational system. So they are not 100% isolated from one another and within the kernel itself. So that's why, yeah.
Got it. And Marcio's got a number of demos for us today. I think you're going to be kicking off the first demo of the day. So really looking forward to that. All right, last but not least, Bill, tell us a little bit about what you do at AWS, and I think maybe a sneak peek into what you're planning to demo for us today.
Sure. Thank you. Thanks for having me. My name is Bill Pfeiffer. I'm a Microsoft Specialist SA. I've been with AWS for about 4 years now, helping customers adopt AWS services as well as move their Microsoft workloads to AWS. I've been focusing on Windows containers for the past 2 years or so, as well as a number of other topics like cost optimization and systems manager. So happy to be here. And today, what I'm going to present is a newly launched feature within EKS for managed node groups. So previously, there was only one compute option, which was self-managed node groups. And in December of last year, we released managed node groups. And today we're going to go over it, kind of deep dive into the benefits of using managed node groups, and how teams can basically get started.
Awesome. I'm excited for that. And when we say December last year, it sounds like forever ago, but it was just a few weeks ago, really. So I think that'll be a fun demo to see here. Okay, I want to start with kind of an open-ended question. A lot of our viewers are familiar, probably, at least the ones that are familiar with Amazon EKS, are probably working with Linux containers. What sort of things should they watch out for? What are the gotchas for these customers that are considering running Windows workloads?
For sure. I'll honestly start by saying that the customers build and run Windows containers is not very different from building and running Linux workloads. And honestly, comparison doesn't really make sense. However, there are some, as you said, gotchas that we do want customers to think about when they're starting to use Windows containers. Of course, keeping aside the specific use cases that make a workload fit for a Windows containers versus Linux containers. The primary difference really comes from the fact that Windows containers take a lot longer to boot, and the reason for that is the inherent size of the base image. The Windows container image can be a few GBs compared to Linux images that are a few MBs. So that of course means that by default, Windows containers take longer to launch. Of course, we'll talk a little bit about how customers can optimize that time, but that is definitely one big gotcha or thing to keep in mind when running Windows containers that you shouldn't really compare, but there is definitely an expectation that customers should have around launch times. The second thing I would add is around monthly patches that Microsoft offers. Of course, folks that are Windows experts probably already know about this, but in a nutshell, Microsoft essentially releases monthly patches and security and other patches through updated Windows Server images. Of course, we do suggest customers to leverage these newly patched container optimized images, either the ones that we directly offer through AWS, or essentially use something like an EC2 image builder to update their custom images that they've created to use for containers, and do that on a monthly basis so that they have the latest security fix. Marcio, do you have anything to add to that?
No, I think you covered pretty much everything. I'm happy to show folks how all these big images actually it's not I would say a problem during the worker node startup, but we have ways to work around that. So that would be great, but it's pretty much it. Go ahead. Sorry.
So Marcio, Purvi had mentioned that launch times are a concern. Yeah. Why are launch times a concern with Windows containers? I mean, is there something that causes that additional time required?
It's pretty much the size of the container image and its intermediate layers. So as Purvi was saying, like the most common use case is .NET Framework applications. So in order to run those applications on Windows container, you also need to have the .NET Framework intermediate layer and then your application. And those intermediate layers, .NET Framework, SDK, WCF, these are big images, like 1 to 2 gigabytes of size. And when you have like many pods on EKS concurrent doing the container runtime, pulling and extract those images within the node, you have some resource constraints. And that's why it takes a while to launch those containers. But we can definitely work around this situation, which I can,
we just got a comment in chat, and I feel like it's a little bit tongue in cheek, but at the root of it, I think it's a valid question. Who uses Windows in the cloud? And so I think there's probably a number of use cases here. You guys see it day after day. Before we jump into that first demo, Marcio, open-ended question here. What are some of the most common use cases for running Windows containers in the cloud?
Absolutely. That's a great question. And more often than not, we actually find folks surprised when they hear about how many customers end up running Windows workloads on the cloud, regardless of the compute platforms they end up picking. of course, I'll keep the discussion more focused on containers for this discussion. So as I was talking a little bit earlier, a lot of customers, run and modernize their .NET Framework workloads that they either are already running on VMs or EC2, or either they've just started their migration journey from on-premises to AWS. So a lot of the usage that we see and use cases that we see for Windows containers is around lifting and shifting customers' .NET Framework workloads, as I mentioned, like as opposed to refactoring and re-architecting these workloads, because it's a very time and resource intensive process, and a lot of different situations that wouldn't even make sense for customers to make that investment. Another, of course, use case that we see is around web apps and Windows services. In fact, a lot of our customers also leverage Windows containers to run third-party and custom off-the-shelf apps. To give you an example, it could be a security tool that that customers are running. Of course, has a dependency on Windows Server, but it's just a workload that's more transient in nature. It's not something that customers want to have as a long-running service. So in a lot of different situations like that, we do see customers leverage Windows containers for third-party tools as well. And of course, sorry, were you saying something?
No, sorry, go ahead.
And lastly, I would also say, I think gaming industry is definitely one of those sectors where we've seen a rapid adoption for Windows containers, because of course they do have systems and workloads that need to burst out quite rapidly into the clouds, and containers kind of help them do that.
Awesome, thank you. Okay, I think before we answer that question, we were going down the path talking about the launch times being a little bit long. Marcio, I think you've got a demo or a diagram to kind of dive a little bit into that particular issue with Windows containers, right?
Absolutely, yeah. So let's set the context of what happens on Windows and Linux as well, and then let's see through a demonstration what happens under the hood when you launch a Windows pod or multiple Windows pods, right? So this is not particular to Windows, but like when you have a new node, Linux or Windows node that joins the EKS cluster, usually through a scale out, whatever mechanism, usually a lot of things start going on here. Kubernetes will start assigning pods to this node, but not only that, we also need to remember that in production environments, usually we have a set of daemon sets for logging, monitoring. So it's not only your pod for app, but it's a bunch of other plugins or daemon sets that needs to be there in order to have full observability. So once you join this worker node, things start happening. And what actually start happening is your container runtime, in this case, Containerg, right? And then pods become assigned. So you have like your application, and let's say this application is based on a .NET full framework application. So you have the layer of your app, the binaries of your app as part of the container image. You have like the .NET full framework layer, and you have the base layer, image layer. So it's a chain of layers that compose your image. But not only that, as I was saying, you also have some daemon sets you set up for like FluentD, FluentBit, or whatever third-party tool for monitoring logging. And those usually require some of .NET stuff or Go for Windows or whatever framework it needs to be there, right? So you have these daemon sets that usually is more than one. And what happens here, Sai, is like everything occurs in the same time. So once the worker nodes joins the cluster, all this pooling mechanism is happening at the same time. Different threads from Containerg, but it's happening at the same time. So you have a pool happening over here for your app, pool over here, and over here for all your daemon sets at the same time. So pool mechanism on Containerg is a parallel thread. So Containerg by default pulls 2 layers at a time for each thread. So let's say you have one thread for your app, one thread for daemon set, let's say FluentBit, and another thread for whatever other pod. So this is a multi-thread. Within each thread, 2 simultaneous pulling at a time. But then after that, you have a not a single thread, but a serial operation to extract all those images on your operational system, right, on the EBS volume. So here is the thing. This also happens on Linux, but the size of the image is so small that usually the worker node doesn't feel that much. So like you might have 1 to 2 minutes of this heavy I/O operation happening in your disk, but that's fine, and then life is good. On Windows, we need to remember that usually all those intermediate layers are big. So now it takes time, not only to pull, but the most expensive operation, extract to the disk, which is a serial operation. So if you are extracting a .NET framework, which is usually 1.2 gigabytes of size, it's going to take a while. But then you also have extraction happening this thread and this thread and this thread. So you have multiple threads extracting at the same time on your EBS volume. Then you have maybe a resource constraint. And I'm going to show you that in the demo. So the whole idea is like when you start up your Windows node group and you are pulling your app and all these daemon sets, you have the container runtime pulling and extract all these images in the same time on your node. And let's see what happens. But not only that, also Windows, by default, there is the Windows Defender, which is an antivirus endpoint protection for Windows that actually kicks in for every time you are extracting an image in the disk. This is by default. So I'm going to show you some workarounds so you can avoid all of that. Okay?
So Marcio, that pull step, so I'm assuming the first time, of course, is going to be the longest. Yeah. Is exactly. For consequent pods that are coming up, is that start time significantly lower?
No, this is just for the time the Windows node join the cluster and you have this pulling at the runtime. Once it finishes, other pods that reuse the same layers won't have this problem. This actually occurs in the first 10 minutes of a life cycle of a node. So the first 10 minutes of a Windows node is when you see all that happen. The problem with that size, like on Kubernetes, usually when you have a lot of IOPS happening on the disk subsystem, you have Kubernetes node pressure, disk node pressure. And Kubernetes, to protect your workload, it might evict some pods which are running in order to reduce the IOP. But here is the thing, all these IOP is happening because of a pull and extract operation, not because of an app. So your application pod can be evicted just because of the behavior happening over here. This is what I'm gonna show you.
Got it.
All right, cool. So let's take a look on the demonstration. And so I have here a Windows worker node. I'm gonna show exactly what happens under the hood. So when you launch a Windows worker node, containerd kicks in, pods are assigned, and then images being pulled and extracted. So what I have here on the top left is a performance monitor where we are gonna analyze CPU consumption of this containerd operation. And right over here in the bottom left, I have disk monitoring. So we are gonna see all these IOPS happening at the same time. Okay. So I'm gonna just use .NET framework application. So let's use an example where I have pods that use .NET framework application, some daemon sets that also use WCF as an intermediate layer, and all these happening at the same time. So let's give some bedtime for this worker node over here. As you can see, resources are minimal, 0% of utilization, right? So I'm gonna just start pushing a lot of pressure here, and containerd is gonna start work.
And we can't read those commands, but I'm assuming those are just like
containerd. Sorry about that. Yes, let me just, it's containerd. So I'm using containerd to pull those images, right? Exactly the same way as Kubernetes will instruct Containerd to do the same. Okay. Oops, let me just go over this one here. And then we have this one here. So it's, it should be working here. So let's give it a time. I don't know why my node.
So
Go ahead.
While this is going, I had a question. Is there a way to optimize this? Maybe maintaining a cache on the cluster itself with the images to make it even faster. Even, for example, if a brand new node comes up and it's not in its local cache, to be able to pull from another node.
Yes, exactly. This is what we are going to demonstrate as a second demo here, because all you want to avoid is bombard our worker nodes with all these IOPS. So we are going to cache those intermediate layers as part of our AMI. I test that many times today, and I don't know why my instance in the live demo is not resolving the name here. But I will keep an eye on it because it sounds like my image is not, my worker node is not resolving the Microsoft repository name. I don't know why. I tested that 10 times today.
Well,
so
when you do it live, it's always different.
Yeah, but the whole idea here, what would happen, guys, is like Containerd has multiple threads happening at the same time, pulling all those images. And then once this process starts, you see an increase on CPU for Containerd. So usually it takes like 100% of CPU utilization on Containerd because Containerd is working to pull and extract, but in the same time, we have Windows Defender that kicks in and start analyzing all those files being extracted to the disk. This is the first behavior, and we want to avoid that, right? The second one is the amount of IOPS happening in the disk, because once the container runtime extract the extraction of each image, then we see this concurrent extraction happening at the same time, and we see an increase on disk write per second, right? So depending of the size and depending of the type of disk that usually we use GP3, it might take a hit when everything happens. I'm really sorry about that. I don't know why. Let me just close my PowerShell and try it again, a new session, but it should be working. If it's not working, that's fine. Okay, just 1 second here. Yeah, I don't know what might happen. It's not resolving the name of this image repository over here. I'm so sorry about that. Okay.
Not a problem. That's why we do it live.
Cool. Yeah, but that would happen. Okay, and so in order to avoid all this behavior within the start of the Windows worker node, as you guys saw someone asking the question, we want to use a mechanism to actually bring all those intermediate layers, not your application layer that might change frequently, but what you want cache are those intermediate layers over here, which are basically from Microsoft. Those are the .NET layers, right? ASP.NET, the base image, and so on. These just don't change frequently. Microsoft releases new updates every month, and then you can just pull those within your worker node. So the whole idea would be, let's set up EC2 image builder as an AMI pipeline. And within this EC2 image builder AMI pipeline, we can have custom components that could pull those images during AMI creation. So the next time you launch a Windows worker node on your EKS cluster and pods are assigned, what happens is that Containerd is going to check, okay, I need those layers. Oh, they are already present in the machine. So I just check the metadata and I avoid all these IOPS of pull and extract on my
Marcio, help me understand here, because we mentioned a few different pieces of technology here. You mentioned EC2 image builder, and then we talked about the actual AMIs, the Amazon machine images, but we're in the context of Amazon EKS. And of course, EKS needs nodes to run on, these nodes being EC2 instances. So what's the EC2 image builder, and where does that fit into the puzzle here for helping us cache these layers?
Yeah, so as I was saying, like, we want to avoid this situation with Windows. We want to pre-cache those container images within the AMI, okay? So EC2 Image Builder is an AWS service that creates a AMI pipeline. And you can also build a pipeline to build container images. Not support for Windows, but AMI Windows. So the whole idea is, if I need a custom EKS AMI to cache all those container images to avoid this situation, I could use EC2 Image Builder to streamline this pipeline. Okay.
Got it. And do you necessarily have to use Image Builder? Could you use, could you build an AMI using other build approaches, as long as it's a VM image with the right, cache layers for the Windows image? We should be good, right?
Absolutely. You could use any other tool. However, one of the functionalities that I do like from EC2 Image Builder is another component called Fast Launch. And this is another component which is very, very important for Windows. So here what happens, like, when we create a custom AMI, and then we deploy this custom AMI as part of our Windows worker node, Windows operational system, there is a process called sysprep. Sysprep is a process within the operational system that there are two steps. One is to remove a security identifying number. So in a Windows network, and the security, the fundamental building block of a Windows security component is SIDs, security identifiers. So each component in a Windows network, there is this ID, this SID. So every time you launch a new custom AMI, the sysprep process kicks in order to create this SID number, which is a randomic number for each instance. So every time you launch a new instance for a custom AMI, sysprep process kicks in and then generates this ID number. This process itself, it takes around 6 to 7 minutes. This is a Windows system thing, and there is nothing you can do to accelerate, nothing like that. It just happens. So imagine that if you launch a Windows container instance on your EKS cluster, and you don't have cache, it's going to take 6 minutes to pull and extract all those container images on your worker node. But not only that, the worker node might take 6 to 7 minutes to join the cluster if you're using a custom AMI because of this sysprep process. So what we could do is to enable fast launch. And this feature, fast launch, actually was a brilliant work from our engineers that provide custom AMIs with a snapshot in the customer account where the sysprep process already occurred. So fast launch new EC2 instance in the customer account, let sysprep to finish, then we take a snapshot of this process and store as IBS snapshot. So the next time a new Windows worker node needs to join the EKS cluster, the AMI in use is actually this EBS snapshot that was took from the fast launch, and then all the sysprep process is already finished. So let me show here a quick, this demo will work, so don't worry about that. So let me just here. So can you see my screen?
Yes.
Perfect. So I have two instances here. One where I have, it was launched by a custom AMI with fast launch enabled and another disabled. So let me show you the behavior of Windows and custom AMIs. So when you launch a Windows, EC2 Windows with a custom AMI, let's take a look on the launch time. This is the time I launched my EC2 instance. So this is the time the EC2 API run instance received my call, okay? So let's focus on the minute column here. So it was around 9 p.m. to 9 minutes. This is when EC2 control plane received the call. But now let's take a look at actually how long it took for this instance to finish sysprep. So from that call, it was the minute 9, we see that the sysprep took almost 6 minutes to finish. Windows sysprep configuration complete. So this is the time your EKS cluster is going to be just waiting for the Windows worker node to join the cluster. And you want to avoid that. And you want to avoid that, like as I was saying, this fast launch functionality can be enabled by EC2 Image Builder through your pipeline. And here is the result. So if you launch this Windows worker node through a custom AMI with a fast launch enabled in this custom AMI, again, let's take a look on the minute column here, okay? It was 9 and 8. How long it took this sysprep process? Just 1 minute and a half, from 8 to 10 here. And why? Because the EC2, the fast launch functionality is just offering an EBS to the EC2 that this sysprep process already run. So you can avoid all this time it takes for a Windows to start up and join the cluster. Okay.
Okay, so I'm sold. When you have these kind of custom packages, it makes sense. Use the AWS optimized AMI, but use the image builder on top with that AMI to create a custom AMI. That's going to enable you to have faster launch times, especially when using this fast launch feature.
Yeah.
But sorry, go ahead.
No, one thing to point out is like the EKS optimized AMI, they already have this fast launch enabled under the hood, right? Mm. However, if you want to implement this cache strategy we were talking about, you need to create a custom AMI where this fast launch functionality is not there. Then we need to enable it manually. Okay.
I understand. So if I understand, you have a demo for us with actual EC2 image builder today, right?
Yeah, I'm gonna actually show for you guys a pipeline that you can create with EC2 Image Builder. And this with EC2 Image Builder, you have image receipts.
Can you make that bigger? Can you make it bigger?
Yes, I can. Is that better?
Yeah, that's perfect.
So you can have multiple receipts of the image to be built on your pipeline. So here is an example where I'm using one to build a optimized EKS custom AMI. Okay, so as you were saying, I'm using the EKS optimized AMI as base, but then I'm gonna add some custom components to it. So here is an example. With the EC2 Image Builder, I'm using the EKS optimized AMI Windows, which is created by Amazon. So we take our Windows vanilla AMI and we add this EKS component that actually make it EKS optimized AMI, all right? And then the next step is a custom component, which I call container pool. With this component, I can create a YAML file here where I can set a bunch of parameters. And one of those is, connect to my ECR repository, but not only that, pull that image and pull all those intermediate images we were talking about. So once the pipeline runs, go through all these components and output the custom AMI for me. So this is how it works. It's very nice.
That's a pretty graceful solution. I think being able to preload that cache with the images makes a lot of sense.
Yeah. And again, you should pre-cache intermediate layers like .NET framework and so on. And even your application layer, if that application doesn't change frequently. then it makes sense. Otherwise, you can just leave it aside and work with those layers here. Okay.
Awesome.
Cool.
So Matthew, I do want to take switch gears here a little bit. I know there's another logging demo we wanted to show, but Bill, if you're ready, I want to actually jump to the managed node group piece here to make sure we have enough time to get to that. I know that that's a new capability we've recently released. Should we switch scopes here?
Absolutely.
Let's do it.
Sure.
And based on the demo we just saw, Bill, I guess a question for you: these custom AMI images that are created, through this EC2 image builder, can we use that with, this new feature you're about to show with managed node groups?
Yep. So I'll kind of go into that a little bit here, but when you're using managed node groups for Windows worker nodes, you are able to specify a custom launch template. So when you do that, you can still get the benefits of automated provisioning, the lifecycle management, the same workflow and tools as Linux nodes, but you can also specify a custom launch template. And in the launch template, you can have the custom AMI included. So that basically opens you up to use MNG, but then also use the EC2 image builder pipeline to build the caching strategy. So you can kind of have the best of both worlds. And with that mentioned too, there's a couple nuances with it when you're adopting that. If you do specify a custom launch template and you include an AMI ID, you will have to go back in and recreate the user data that's used to join the cluster, or to bootstrap the worker node to join the cluster. So that is one caveat to keep in mind. But if you don't specify an AMI ID within that launch template, that is already handled for you on the back end as part of like the automated benefit of using MNG, right? The bootstrap of the node and join the cluster. So the answer is yes. But to dive into managed node groups, so managed node, previously we only had self-managed node groups as the compute option for Windows worker nodes in EKS. And that meant basically, you could use some tools like EKS CTL to be able to provision those self-managed node groups, and it will do a lot of the scaffolding for you. But at the end of the day, you are responsible for the life cycle of that full infrastructure. When adopting managed node group, you are using the same functionality that Linux worker nodes use today. So what you basically get is automated provisioning, automated lifecycle management in the simplicity of using, one-liner commands, right, to be able to either provision an MNG, scale an MNG, and there's a bunch of other benefits too, like you're getting tags right off right from when the nodes are provisioned, so that they're enabled for the cluster autoscaler. And the other piece that's important, distinction between self-managed nodes and managed node groups, is also the graceful termination of nodes. So when EKS is going to terminate one of the nodes, it will automatically drain it and communicate with the Kubernetes API to make sure that the node isn't just automatically terminated from underneath the cluster. It goes through a graceful termination cycle. One thing to keep in mind too is that as you're looking at the documentation for MNG, it is using all of the same commands and tools as its Linux counterpart. The one key difference that you'll see is these 4 AMIs, right? These AMI families has what's been introduced. So we're supporting Windows Server 2019 and 2022. Both in core and full flavors, depending on your operational needs, or if there's some sort of dependency. We offer both AMI flavors. So these are the 4 inputs that you would use when either updating MNG or provisioning an MNG or adding a new MNG. So one thing to keep in mind for sure. Now, these M&Gs, because they're using the same tools and workflow as its Linux counterpart, AWS CLI, CloudFormation, Terraform, EKS CTL, these are all supported using Windows Managed Node Groups. If you're like a lot of my samples here are going to use EKS CTL. So when you're provisioning a new cluster, say net new cluster, and you're going to include Windows Managed Node Groups, EKS CTL will automatically patch the config map to include the Windows IPAM component so that you can basically retrieve IP addresses from the VPC. And when you're going to choose your AMI family, it's important to note too that if you're going to use Windows Server 2022, your Kubernetes version should be 1.23 or higher, right? Otherwise, you're not going to have a good time. When we're looking at an EKS CTL example, it's as simple as just like a Linux managed node group where you could specify a node group name and then your AMI family like we looked at previously, but it's the same setup as you would with a Linux managed node group.
Can you make that a little bigger? I didn't
sure.
know that you could. Yeah, I was trying to find if this example existed in the EKS control examples repo, but I know managed node groups is new, so I don't think it does. So if anyone's interested, EKS control has a whole folder full of examples you can go check out. And Bill, I think we should PR this. If this is, since it's a newer feature too, there's some other Windows examples there for running Windows node groups and running Windows with containerd. I don't see any for managed node groups, and I think that'd be an awesome addition there, just to be able to copy and paste, create a cluster, and see how it works.
Yeah, no doubt. We do have a blog coming out here within the next week or two that will demo this, but I agree we should patch the docs so that there's a consistent experience if it's not included.
So, Bill, I have a quick question before you proceed. So,
sure.
You mentioned that EKS CTL is patching the config map to enable the IPAM component. Is this something smart that EKS is doing? It's recognizing that, hey, I see a Windows managed node group. Let me go run this other separate special thing. And I ask that because if customers are doing this in Terraform or clicking through the UI to make a cluster or whatever else they might be doing, is that an actual manual step that they have to be cognizant of?
Yes. So that's a it's a feature that's automatically doing that for you when you're using EKS Cuddle or CTL, whichever flavor you want to use here, and that is done for you. Say if you went and used AWS CLI and you provision this, you could get the managed node group online. It'll bootstrap and attach to the cluster, but then you go to schedule pods against that Windows M&G, and then you'll basically go through and describe the pod, see that it's in a container creating state, and you won't be able to actually get the pod online. And if you describe it, you'll be able to see missing label, Amazon IPv4 private IP address. So then you have to go back through, and there's documentation that basically will enable the Windows IPAM feature for you. So then if you were to go through and edit the config map for Amazon VPC CNI, you can go back in and basically take a peek at that. Where one sec. If we were to go in and take a look, hold on here. Let me grab this. So if we were to take this, we can actually go back into the config map and actually see if that feature is enabled, which in my case, it is, right? I already had this set up previously, and this was a cluster that we provisioned the managed node group directly from the get-go.
Got it. And that seems fairly straightforward. So if I take any old Kubernetes cluster, EKS cluster I have lying around, all I have to do is patch that in the CNI config, and now I can start making Windows managed node groups.
Yep.
Cool.
Yeah, and there's there's documentation too for enabling Windows support. So in the public documentation, this is clearly stated as well. So something to just keep in mind for viewers. Now, one thing too is that you are able to add a managed node group to an existing EKS cluster. So if you're going to adopt managed node group after the fact of provisioning the cluster, you're able to go through and also do this. So if we were to go through and provision this against an existing cluster, we would be able to basically kick off the process, which is going to create the necessary CloudFormation templates and provision the managed node group, which will then, connect that to the specified EKS cluster. And then that's one way to do it. So if it's an existing cluster, managed node group is fully supported to be included. If it is a new cluster, you could just provision that, and all of those steps will be done for you. And as you can see, once we kicked off the add, you could see the stack instance already created, and it is going through and provisioning the managed node group on the back end, and then attaching it to the existing cluster.
Got it. Bill, I've got to say, this almost feels like necessary to work with Windows on Amazon EKS. What did users do before the managed node group support?
So you could go through, and when you would provision this, you would just have a node group, and EKS control would make this process smooth, where it would provision all of these pieces for you. So, but the thing afterwards is that updates were all on you. You didn't get the graceful termination. You don't have any of the resource tags automatically included. So there's a number of benefits that you would get from just using managed node group. When you're making that determination of should I use self-managed or managed, with the introduction of using the custom launch template, there isn't an immediately compelling reason to use self-managed node groups, because you have that flexibility with the custom launch template.
Got it.
So I was going to go into just kind of a quick kind of underpinnings of the managed node group, but I just wanted to do a time check. Do we want to jump into it, or?
Yeah, I want to make sure we have a few minutes here for Q&A. So for folks that are watching, if you have any questions, while we have our experts on the line here, drop some questions in the chat. We'll spend some time at the end going through them. I already see a couple of questions here that we can circle back to at the end here. But Bill, I'd say we have a few minutes here if there's something else you want to show, or Marcio, if there's anything you want to show.
Marcio, do you want to do a quick overview of the logging piece?
I just fixed actually my first demo, but I don't know. I think we could just finish the one I promised for you guys, which is way more important, and you can go from there.
Let's circle back to that first demo. Let's because I wanted to see that spike in the resources and
yeah,
see
me too. I was very sad when this thing didn't work. So I'm so sorry about that.
I love the live debugging aspect. What happened? Because we were just pulling an image from a registry.
It was my mistake. I misclicked one of the subnets. When I launched 10 instances today in the right subnet, in this one I did a mistake. I don't know why.
That's how it goes.
Okay, so what I'm doing here, I'm just gonna again create 3 different threads so we can spin up 3 different images being pulled. So this is one, this is the .NET one, and here is Container-G. Container-G command line, I'm gonna just set up KS IO as a namespace, and I'm gonna pull the image over here, okay? And okay, now so we are gonna just simulate here, guys, multiple images being pulled in the same time. I'm gonna just come back and explain to you all what's going on behind the scenes. But this is pretty much your Windows working node. Just join the cluster, and then all these daemon sets, all your pods assigned, and the container runtime is pulling all these images. And as you can see, now my CPU, it's hitting 100% of utilization. And let's just take a look what's consuming that much. And this is a brand new window, so it's good because we are seeing all the OS routines happening right now at the same time, exactly what happened when a Windows worker node joins the cluster. So we can see that Container-G is consuming 62% of the CPU, but then we also have the Windows antivirus that kicks in and is checking for all the data being saved on the disk that also consumes CPU. And then we can see on the disk that the EBS is being hit very, very hard, with being the red disk writes operation and the in green disk reads operation. So if I don't, this is the pain you will face if not using a custom MI, because as I was saying, this node just joined the cluster. And this node, in the early beginning, there is a resource constraint. And now, if one of those pods, being the daemon set or your application, reach the running status, Kubernetes for this node might look at, hey, this is a no disk pressure happening right now. So I'm going to evict any other pod in this node in order to prevent the application to go down and poor performance if traffic comes to this application. So you can have pod eviction really in the beginning of the Windows worker node joining the cluster. Not because of Kubernetes, EKS, or Windows container. It's just the Container-G working very hard to extract all those images over here. And as you can see, now Container-G, for each thread image, is actually in a serial process. It's extraction layer by layer. And you can see that the CPU and disk is all on top. So any pod that receives traffic from this worker node is going to have a poor performance, right? And the whole idea of custom MI is to avoid that. So we want to avoid that. And the custom MI is going to save your day with that kind of approach.
Only we could use Graviton instances with Windows, right?
Oh, yeah. I hope. Well, with .NET Core, you can, right? But unfortunately, with .NET Framework and Windows is not supported yet.
Yeah. I guess, the other option, just get meatier nodes, but this is probably the more graceful solution to preload some of these caches.
Yeah. One thing side that from multiple tests is like, it really is like, depending of the size of the node, the difference of performance in those 10 first minutes of the life cycle of the node is not going to change much because the CPU can handle, but the EBS is the one being hitting very, very hard. So you might drop your CPU utilization, but the EBS is on 100% utilization, right?
Makes sense.
And that's really fascinating, just the different ways you can solve this problem, right? Because in the world of containers, you can make the containers smaller, if that's a possibility. In Windows, it's not. You can make your network faster, but your bottleneck is still EBS. Yeah. And EBS, you have options to make that faster by using an I/O disk or making the disk bigger. You get more IOPS per second throughput, but you probably don't need that much storage.
Exactly.
You can get a terabyte disk and like, oh, I got all the IOPS in the world. It's like, oh, but now I'm wasting,
Exactly.
hundreds of gigs that I don't actually need. I just needed the IOPS. And so optimizing this during build time means you have to do that one time instead of every time the node boots. And you can use those slower disks or smaller disks with less IOPS overhead that are cheaper. So you can optimize your costs long-term, because that's where the actual, like, you're running this for hours or days or years. The first 10 minutes only matters for that performance of we need to scale up or we want this to, kick off a little faster. So it's fascinating to see all those different options for how you could solve the problem, and solving it at build time is the right solution here.
Yeah,
absolutely. So we've got just a few minutes left here, Marcio. If we can answer the question in a minute, I think we've got time. Sure. So we've got a question in your demo. Why would you pull server core and ASP.NET? Is it not already included in the EKS optimized AMI? And I think that's a good question. Why don't we just...
This is a good question. This is a good question. I just built for my own purpose, but this is true. Like when you use a EKS optimized AMI, we ship this EKS optimized AMI with server core and nano So server core LTSC and nano LTSC are read within the AMI. Okay. So in my component, I have that. But here is the thing. Why, Marcel, you have that? Remember that Purvi said that you need to keep those base images up to date, right? Mm-hmm. So let's say I don't want to wait for AWS to launch a new EKS optimized AMI. I want to apply a patch between this 1 month. So what if I have that base image over there, I'm gonna force the pipeline to pull the latest version from Microsoft anyway. So this would be an option, right? Just to keep the update between the time we launch new AMIs, which is every month. But yeah, you don't need that if this is not the case.
Got it. All right. As a last question here, maybe open-ended, anything you want to leave our viewers with, ways to get involved, ways to contribute, ways to get started with Windows on AWS with EKS. Any final things you want to leave our folks with?
Yeah, we have. I can share one. It's a personal one. I am about to launch a book, which is running Windows containers on AWS, and is a complete guide on successfully running Windows containers on Amos ECS, EKS, and Fargate. It's in pre-sale. It's going to be published on May 9, 2023. And this, like on the book, we dive deep in all this stuff. I just explained all this stuff that Bill explained too, and some use cases that Purvi shared as well. So I hope this book will help folks. I can definitely share the URL.
Yeah, congratulations, Marcio. When you have a link, remind me. We'll add it to the description of this episode. It's not available yet, right? So as soon as it's we'll add the link in the description to the video.
Okay.
Cool.
Yeah, I have some parting thoughts. I mean, honestly, if I were to leave this, leave the viewers with something. Honestly, if your applications can run on Linux, you should run on Linux containers. You should move to Linux containers. But we know there is a large chunk of workloads that are still dependent on Windows Server. And for them, we do think Windows containers is a great option. There is a very cool tool that we developed, I think a couple of years ago. It's called After Container, which essentially helps customers or essentially identifies the applications customers are running on their IIS server and helps containerize them. So if you're new to the container world and you do have some applications that are running on EC2 or in general VMs, and I would highly recommend trying that out because that will give you a good sneak peek of what it is like to containerize an application and run on containers. Of course, there's a bunch of other resources. You can reach out to us on Twitter, email, and of course, I'm sure you'll share those things with our viewers to comments. So, yeah.
Excellent. Thank you so much. All right, folks. Well, Bill, 1 second here. Anything else you want to leave our folks with here, or are we good?
I think we'll include a link to this, but we do have a workshop that does cover both ECS and EKS in detail, including Fargate. So if you're looking for a self-service approach, or you would like to run an immersion day for this content, feel free to reach out to your account team and we could put something together for you.
Excellent. Justin, any comments?
No, this is great. I learned a lot. I love seeing just how things have come, but also how far things have come in the past. But even from my old Windows admin days, I'm a little sad that like sys prep still takes a long time. I remember dealing with that back in the day.
Awesome. Well, thank you to our guests, Marcio, Purvi, Bill, for coming on today. I learned so much today. Hopefully it was helpful for our viewers as well. For folks watching at home, be sure to subscribe to Containers from the Couch to catch more episodes like this in the future. And we'll catch you next time.
Thank you.
Thank you.